collinearity. Collinearity of points in three-dimensional geometry, the collinearity of the points. Okay. If A x1 y1 z, B x2 y2 z, C x3 y3 z be collinear points, then AB plus BC equal to AC, or AB plus BC equal to AC. The distance between AB plus the distance between BC is, suppose it is the distance between AC, then ABC are collinear. Or similarly, AC plus CB, the distance between A to C and C to B, is equal to A. Similarly, CA plus AB is CB. If any one of these relations follows, then you can say that the 3 points are collinear. In this case, AB plus BC equal to AC. In this case, AC plus CB is AB. In this case, CA plus AB is C. So these are all the three cases. Once any one of the case happened, satisfied, then ABC are said to be collinear. Otherwise, or area of triangle ABC is 0. Area of triangle ABC is 0 also gives us the collinearity of the given points. Area of triangle ABC is 0. Then the points ABC are said to be collinear. Now the condition for collinearity. Now condition for collinearity is condition for collinearity of ABC. AX1 y1 z1, BX2 y2 z2, CX3 y3 z3 is x1 minus x2 by x2 minus x3 equal to y1 minus y2 by y2 minus y3 equal to z1 minus z2 by z2 minus z2. So this is the condition for collinearity of ABC. Based on these conditions, you can develop that one. Here B divides AC in the ratio AB is to BC. So based on that, you can able to find that condition. So the condition for collinearity is this one. Run this. Okay. Once next point. If ABC are collinear, and AB plus BC equal to AC. That means that is B divides AC. B divides AC. Then the ratio in which B divides AC is, B divides the line segment AC is x1 minus x2 is to x2 minus x3, or y1 minus y2 is to y2 minus y3, or z1 minus z2 is to z2 minus z3. So the ratio in which B divides, the ratio in which B divides AC is, that means AB is to BC is given by, based on the x coordinates you can find that ratio, or based on y coordinates you can find that ratio, or based on z coordinates you can find that ratio once B divides AC. Similarly, you can develop the ratio in which C divides AB and A divides CB also. So these are the points related to collinearity of the points. Once ABC lies on a same line, then the relation between the coordinates of the collinear points. This is one important concept, area of triangle. Area of triangle. Suppose A is the point x1, y1, z1. B is the point x2, y2, z2. C is the point x3, y3, z3. A x1, y1, z1, B x2, y2, z2, C x3, y3, z3 be the vertices of a triangle. They forms a triangle. Area of triangle. Triangle ABC. Area of triangle ABC is given by half into determinant of x1, x2, x3, y1, y2, y3, 1, 1, 1. Okay. Square. This is half to that of the square root of square plus x2 x3 x1 x2 x1 x2 x3 z1 z2 z3 1 1 1 square plus determinant of y1 y2 y3 z1 z2 z3 1 1 1 square. So the area in three-dimensional geometry, the area of the triangle formed by the given non-collinear points, given by non-collinear points is half into under root determinant of x1, x2, x3, y1, y2, y3, 1 1 1 square plus determinant of x1, x2, x3, z1, z2, z3, 1 1 1 square plus y1, y2, y3, z1, z2, z3, 1 1 1 determinant square. Actually, this determinant gives us the square of the this one, half to the top x1, y1 1, x2, y2 1, x3, y3 1. This determinant gives us the area of projection, of triangle ABC on XY plane. I will show is like this. X-axis. This is Y-axis. This is Z-axis. Let us consider A, B, C. 3 non-polar points. The projection of triangle ABC. Here ABC are in space. The projections of ABC are considered in XY plane. Here x-axis is like this, x-axis is like this. This is our XY plane. You are taking projections. Projections means foot of the perpendiculars. Once you consider the foot of the perpendiculars from vertices of the triangle to the coordinate planes, either XY plane or YZ plane or ZX plane. Once you consider this projection of the triangle, projection of the triangle on a XY plane, a coordinate plane, this area is given by this one, half, and determinant of x1, x2, x3, y1, y2, y3, 1, 1, 1. Because the projection of A on XY plane is x1, y1, 0. This is the projection of B on XY plane, which is given by x2, y2, 0. On XY plane, Z coordinate is 0. This is the projection of C on XY plane, the point. Once you join these projection points of the vertices in the XY plane, that gives us, the triangle gives us the projection of triangle ABC on XY plane. It gives us the projection, area of the projection of triangle ABC on XY plane. This is on XZ plane. This is the projection that gives us the projection of triangle ABC on YZ plane. So these are the projections, areas of projections of the triangle ABC over XY, YZ, XY, XZ and YZ planes. So based on that projections, you can able to find the area of triangle ABC. That is here half x1, x2, x3, y1, y2, y3, 1, 1, 1. Suppose let be x gives us projection of area of the projection. Area of projection of triangle ABC on XY plane. Similarly, half determinant of x1 z1 1, x2 z2 1, x3 z3 1 is suppose ay gives us area of projection of triangle ABC on XZ plane, and half to that of y1 z1 1, y2 z2 1, y3 z3 1 is AZ is area of projection of triangle ABC on YZ plane. YZ plane. So the projection of triangle on a plane is again a triangle. So these are the points in space. Once you consider the foot of the perpendiculars on XY plane or YZ plane or ZX plane, the corresponding projections, feet of the perpendiculars, once you join those feet of the perpendiculars, again you get a triangle which is nothing but the projection of the original triangle. So consider the projections of the triangle in this space to XZ plane, to YZ plane. to zx plane, and taking that projections of the triangle is ax, ay, az, then the required area is half the square root of ax square plus ay square plus az square. So that is, so therefore triangle ABC area equal to half into square root of ax square plus ay square plus az square. This is our formula for getting of triangle ABC. This is the Cartesian form of finding the area of triangle. Once the given points are in Cartesian in ordered triplets in Cartesian form, then you can able to find the area in such a way. It is a little bit laborious process, finding of the projections of given triangle over the coordinate planes and finding those areas and collecting that areas. This is a little bit lengthened procedure. Instead of that, once you go through the vectorial method, it gives us a simple formula to us. Area of triangle, the same triangle area in the space is given by half modulus of AB bar cross AC bar. This is the, in vector form, the area of triangle, or let us consider 1 by 2 into BC bar cross BA bar, or half into modulus of CA bar cross A. The cross product of the vectors. Of course, we will discuss that formula in vectors. Once we go through the vector algebra, we can go through that formula. Till then, you have to remember this formula. Finding of the area of triangle. Finding of the area of triangle. You can develop the projections of the area of triangle over the coordinate planes, and then find the required area of the triangle with the formula, with that formula particularly. Now we will go through the problems, the related problems here. These are the points which are related to coordinate system, three-dimensional coordinate system. Based on that, we will go through certain problems. Okay. Let us take this problem. L comma M are the feet of the perpendiculars from 2, 4, 5 to the XY plane, YZ plane, respectively. Then the distance. Then the distance LM is. If L, M are the feet of the perpendiculars from 2, 4, 5 to the XY plane, YZ plane respectively, then the distance LM is. Okay. Let us take this is OY, this is OX, and this is OP. Let the point be P. 2, 4, 5. Feet of the perpendiculars. Let us consider the foot of the perpendicular. Let us consider the foot of the perpendicular from P to 4, 5 to XY plane. Let it be Q. And YZ plane. YZ plane means it is towards the plane YZ. Back to that of the board, let us suppose like that. Okay. So once L and M, of course, L and M. Once you take the feet of the perpendiculars from P to XY and YZ planes, then you have to find the distance between L and M. Let P is 2, 4, 5, which is in space. Now foot of perpendicular from P to XY plane. Foot of perpendicular from P to XY plane. On XY plane, z coordinate is 0 and 2, 4, 0. This is L here. Similarly, foot of perpendicular from P to YZ plane. YZ plane. That is M here. M is on YZ plane, x coordinate is 0. So 0, 4, 5. So these are the feet of the perpendiculars from the given point P to coordinate planes XY plane and YZ plane. Therefore, the distance between LM is the distance between 2 points here by distance formula, that is 2 minus 0 whole square plus 4 minus 4 whole square plus 0 minus 5 whole square by distance formula, which gives us 4 plus 0 plus 25, which is root 29 here. So based on the feet of the perpendiculars, you can find the distance between the feet of the perpendiculars from P to XY plane and YZ plane. Similarly, you can take the foot of the perpendicular from P to XZ plane. XZ plane is like this. From this point, you can take the perpendicular distance. Suppose XY plane is P is here. You can take the foot of the perpendicular from P to XZ plane. Okay. So based on the feet of the perpendiculars, you can find the required distances. Next one. Next one. Zero, 4, 1. B is A, B, C. C is 4, 5, 0. D is 2, 6, 2. Or the consecutive vertices of a square, then the distance BD is, then distance BD is once ABCD are consecutive vertices of a square, then distance BD, the diagonal BD. Suppose this is the square here, ABCD are consecutive vertices of the square. A is 0, 4, 1 and B is ABC here, of course, and C is 4, 5, 0 and D is 2, 6, 2. It is a square. AB equal to BC equal to AB equal to BC equal to CD equal to AD. So ABCD is a square. Implies and implied. AB is parallel to CD, again BC is parallel to AD, and AB equal to CD equal to BC equal to AD. Okay. Moreover, angle ABC, angle B is 90 here and D is also 90. So ABCD is a square. So therefore, in the square the lengths of the diagonals are equal. This diagonal length is equal to this diagonal length. So AC is same to the top, BD itself. So to find therefore BD equal to the distance between A and C itself. Instead of finding BD, it is sufficient to find AC itself. The distance between A and C is given by, say therefore, distance between A and C is given by 0 minus 4 by distance formula, 0 minus 4 whole square, 4 minus 5 whole square, and then 1 minus 0 whole square, which gives us 16 plus 1 plus 1, root 18, 9 into 2, so that is 3 root 2 itself. The square or rectangle, the lengths of the diagonals are same. So instead of finding BD, just it is sufficient to find AC here to get BD. Next problem. Name of the figure. Name of the figure formed by 2, 3, 5, minus 1, 5, minus 1, and 4 minus 3 is. Name the figure formed by the points. So here let A is the point 2, 3, 5. B is minus 1, 5, minus 1. C is 4, minus 3. Be the given points. To name the figure formed by these 3 points, let us consider the distance here. AB is the distance is square root of 2 minus of minus plus 1 whole square, 3 minus 5 whole square plus 5 plus 1 whole square. That gives us 9 plus 4 plus 36. So, root 49 gives us 7. Similarly, find BC, the distances. Minus 1 minus 4 whole square. 5 plus 3 whole square. minus 1 minus 2 wholes. By distance formula, just I am taking here the distance between BC, which is 25 plus 64 plus 9 itself. That gives us 89 plus 9. 89 plus 9, root 98. 7 root 7. CA. Taking CA here. The distance between C and A is 4 minus 2 whole square minus 3 whole square plus 2 minus 5. That gives us 4 plus this is 36 plus this is 3 square 9, which gives us 7. So from these three distances, you can observe that from these three distances, here we can observe that AB square plus CA square, AB square plus AC square is BC square. Clearly, AB square is 49, CA square is 49, 49 plus 49, 98. So that is nothing but BC square. Hence, therefore, triangle ABC is a right angle triangle. Right angle triangle. So the figure formed by the points is a right angle triangle. Another problem. If the extremities of a diagonal of a square are 1 minus 2 3 and 2 minus 3 5, then the length of its side is, if the extremities of diagonal of a square are given, ends of the diagonal of a square is given, then the side length. This is very easy. Let us suppose A, B, C, D are the vertices of a square. A is given 1 minus 2 minus plus 3 and C is 2 minus 3 5. Be the extremities of the diagonal. Then side length of the side. Here AB equal to BC. So AB square plus BC square equal to AC square implies twice to that of AB square takes the value AC square itself. Hence AB equal to 1 by root 2 into AC. Find the distance between AC here. Once you find the distance between AC, you can find the distance AB itself, the side. So side AB length equal to 1 by root 2 into diagonal length. Diagonal length is the square root of 1 minus 2 whole square by distance formula. This is minus 2 plus 3 whole square. This is 3 minus 5 whole square, which is 1 by root 2 into the square root of 1, again 1 here, plus 4. which is root 6 by 2, that is root 3. Length of the side of the square is root 3 units. Next, basic. This is also basic. If A comma B are the feet of the perpendiculars, feet of the perpendiculars from 2, 4, 5 to the x-axis, y-axis respectively, then A. The feet of the perpendiculars from the point to the x-axis and y-axis, coordinate axis, not coordinate planes. The feet of the perpendicular from the given point in the space to axis here. Let P is 2, 4, 5. Foot of perpendicular from P to x-axis, that is A. On x-axis, y and z coordinates are 0. Hence, the foot of the perpendicular from P to x-axis is 2, 0, 0. That is A here. Similarly, foot of perpendicular from the same point P in the space to y-axis. Let it be that is B here as per given data. On y-axis, x and z coordinates 0, so that the point foot of that perpendicular is 0, 4, 0. X, z coordinates are 0 on y-axis. Therefore, AB distance, the distance between 2 points is 2 minus 0 whole square plus 0 minus 4 whole square plus 0 minus 0 whole square, which is nothing but 4 plus 16 plus 0 root 20 2 root 5 units. The foot of the perpendiculars from the point in the space to the coordinate axis are different from coordinate planes. In previous problem, we consider the feet of the perpendiculars from the point to the coordinate planes, xy plane and yz plane, like that. The feet of the perpendiculars from the point in the space to coordinate planes are different and coordinate axes are different. Okay, here I am taking the feet of the perpendiculars from the point P to coordinate axis, x-axis and y-axis. Similarly, you can find the foot of the perpendicular from the point to the z-axis also. That is 0, 0, 5. You can able to find that point also here. figure formed by these points, is determined by the sides or the distances from A to B or A to C or B to C. So the distance between A and B, that is square root of 3 plus 1 whole square plus minus 5 minus 0 whole square x-axis, equidistant from 1 to 3, 1 2 3, and 2 3 4. Then the y coordinate of the point P. In notation, it stands for y coordinate of the point P. The point P is on the y axis, and P is equidistant from 1 2 3 and 2 3 4. Then y coordinate of P. P lies on y axis. That implies P may be considered 0 on beta. On y axis, x and z coordinates are 0. Let the given points be A and B. Given P is equidistant from AB, that is PA equal to P. Therefore, the distance from P to A is 0 minus 1 whole square plus beta minus 2 whole square plus 0 minus 3 whole square equal to PB square root of 0 minus 2 whole square plus beta minus 3 whole square plus 0 minus 4 whole square. Squaring and removing the square roots, we get 1 plus beta minus 2 whole square plus 9 equal to 4 plus beta minus 3 whole square plus 16. From this you can find beta value. Therefore, 10 plus beta square minus 4 beta plus 4 takes the value 20 plus beta square minus 6 beta plus 9. We can remove beta. Selecting the like terms, beta terms, we get 2 beta here plus 14 minus 29. Otherwise, 29 minus 4. 2 beta takes the value 50. So beta is 15 by 2. What is beta? Beta is y coordinate of P. Therefore, the y coordinate of P is given by 15 by 2. Any point on y axis can be considered as 0, beta, 0. On y axis, x and z coordinates are zeros. On x axis, y and z coordinates are zeros. On z axis, x and y coordinates are zeros. Next. coordinates are given by 1, minus 2, 3, the extremities of the diagonal. C is 2, minus 3, 5. Suppose A and C are the extremities of the diagonal here. One diagonal, you can take BD also. Once AC, the extremities of the diagonal of the square, ABCD, then its area. Let us suppose this is B. Once this is B, the area is B square by 2. That is the formula. The diagonal length is B. The area of the square is B square by 2 itself. So area of square for given diagonal is 1 by 2 B square, where D is length of the diagonal. Length of the diagonal is D. That is here base. The distance between A and C is 2 minus 1 whole square, minus 3 plus 2 whole square, that is also 1, 5 minus 3 whole square, 4, which is root 6 by distance formula. Therefore, area is required area equal to, or you can written 6 by 2, 6 by 4, which is root 3 by square. Once the diagonal is known to us, straight away B square is this is square, this is square, and this is square. That is 2 by 2. So once D is the length of the diagonal of the square, then its area, then the line segment AB in the ratio minus Z1 is to Z2, where Z1 Z2 are the Z coordinates of A. Similarly, YZ plane divides AB minus X1 is to X2 ratio. Therefore, P is to Q equal minus X1 is to X2, where X1 X2 will be the X coordinates of both A and extremities of the line segment. So therefore, P by Q is minus Q by the external division. Then the ratio of division is minus 2 is to 3. Therefore, A by B plus B by Q equal 5 by 4 minus 2 by 8, which is 15 minus 8 by 7 by the required ratio. Sum of the ratios is 7 by 1. That means here YZ plane. Here YZ plane divides the line segment AB externally in the ratio 2 is to 3. Whereas XY plane divides internally because 5 is to 4. 5 is to 4. The ratio is positive here, whereas the ratio is negative. Once the ratio is negative, that is comes under external division. Once the ratio is positive, the division comes under internal division. XY plane divides AB internally and YZ plane divides externally. Of intersection of AB and the X plane. P is point of intersection of AB and ZX plane. Then coordinates of P. If ZX plane divides AB at P, if ZX plane, suppose this is ZX plane, this is ZX plane. Suppose AB divides, AB may be on both sides of the plane or on the same side of the plane based on the internal and external division of the plane and the line segment. So, P is the point on AB which divides by the ZX plane. Now, the sum of the coordinates of this point, that is the point. So, given A is ZX plane divides line segment AB in minus y1 is to y2. That is minus y1 is to y2 is minus 3 is to 3. ZX plane divides AB in the ratio minus y1 is to y. That is minus 3 is to 2 ratio. At P, of course, at P. That is given here. So therefore, P divides AB in minus 3 is to 2 ratio. Of course, since the ratio is negative here, since the ratio is negative, both A and B are on the same side. Like this. The division is like this. P is an external point. AB in the ratio minus 3 is to 2. So P point by dissection formula or division formula. P divides AB in the ratio minus 3 is to 2 and minus 3 into coordinates of 1, 2, 3 plus 2 into coordinates of y minus 3 plus 2. So collecting the different coordinates here, x coordinate, y coordinate, z coordinate, minus 3 minus 4 by minus 1 here. Similarly collecting y coordinates minus 6 plus 6 by minus 1 here, minus 9 plus 8 by minus 1. So that gives us 7. This is 0 clearly and this is 1. So that is the point P. Once the point P is known to us, therefore Px is 7, Py is 0, Pz is 1. X, Y, Z coordinates. Hence Px plus Py plus 7 plus 0 plus 8. The required value is 8. Trisection point means the point which divides the line segment in the ratio 2 is to 1. That gives us the trisection point. In the triangle ABC, sides or 1 minus 4 minus 5 2 minus 2 f respect then f of x plus f of z. but midpoints of BC is, let it be 1 minus 4, let it be D. Midpoint of CA is given, let it be as minus 5 to 1, and midpoint of AB is F. Now you have to find F. Okay. We have to find the midpoint of AB. Let us consider F is alpha, beta, gamma. Let B is 1 minus 4, midpoint of B. E minus 5 to minus 3, midpoint of C. F alpha, beta, gamma, midpoint of clearly DE is parallel to this one, BA, and DF is parallel to A. Hence, clearly this is a parallelogram. So, A, F, B, E forms a parallelogram. Here, A, F, B, E is a parallelogram. Parallelogram. Hence, midpoint of AD is same to that of midpoint of FE. So, midpoint of FE, the diagonal is same to that of midpoint of AD itself. Therefore, midpoint of FE, midpoint of FE is alpha minus 5 by 2, beta plus 5 by 2, beta plus 2 by 2, and gamma minus 3 by 2. Is the midpoint of FE. Is same to the midpoint of AD. 1 minus 2 by 2, minus 4 plus 3 by 2 plus 4 by, hence, therefore, alpha minus 5 takes the value minus 1, implies alpha takes the value 4. Beta plus 2 takes the value minus 1, implies beta takes the value minus 1. Gamma minus 3 takes the value 6, implies gamma takes the value 1. So the point F, alpha, beta, gamma is given by 4 minus 3, 9. Just add these two and subtract this one, gives you F. So therefore, Fx plus Fz is 4 plus 9 plus. Actually, in this case, directly F is given by A plus B minus C. F, the midpoint of AB is given by A plus D minus E. That gives us F itself. Suppose if you are in need of A, this is a parallelogram. If you are in need of B, this is also a parallelogram. Similarly, B plus E is same that of B plus F. B, the vertex B is given by B plus F minus E. The vertex C is given by D plus E minus A. Like that you can find all the vertices and coordinates of the midpoints of the sides.